Hello guys. Now we're going to do the factor theorem, which is a very close cousin of the remainder theorem. So we know that the remainder theorem states that if some polynomial p of x is divided by ax plus b, okay guys, then we know that if we substitute minus b over a, which is the value of x required to make this 0, okay, you'll get the remainder of the division, okay? It follows, ladies and gentlemen, that if ax plus b is an exact factor of p of x, that is, there's no remainder, we will get p of minus b over a would come to 0 because there is 0 remainder, okay? So the converse of this is the factor theorem. So what we're saying is that ax plus b is a factor of p of x if and only if p of minus b over a comes to 0, okay? So that's how we find factors. We find factors when we get 0 remainder, okay? That's what we're doing with the factor theorem. All right, an example for us. What is the remainder when this one here is divided by 2x plus 1, okay? So what we're going to do is we're going to substitute x as minus a half, which is what is required to make this thing 0, into this polynomial, okay? So we put in p of minus a half gets us 3 times minus a half cubed minus 2 times minus a half squared plus minus a half minus 1. And then we work all that out. We get 3 times minus an eighth minus 2 times plus a quarter minus a half minus 1. So, okay, whittling it down line by line, minus 3/8 minus a half minus 1. Well, that gets us minus 2 and 3/8, okay? So that would be minus 19 over 8, okay? So that is the remainder, okay? That is the remainder that you get when this is divided by 2x plus 1, all right? Okay, so if we want to do this on our CAS device, it's very easy. You just put your polynomial in, call it something like f1 of x, and you get your done. And then you just put in f1 of minus a half, and you get your remainder. How do you like that? Pretty marvellous. Okay, something else for us. Given that x minus 1 and x minus 3 are factors of this, in other words, they don't have any remainder at all, now we've got two little pronumerals lurking in here, okay? We're going to find the values of a and b, okay? A very straightforward application of the factor theorem, okay? We've got our polynomial there. We're going to substitute, first of all, x is 1 into that and equate it equal to 0 because x minus 1 is a factor with no remainder. Then we're going to substitute x is 3 in there into that polynomial and equate that equal to 0 because that one also has 0 remainder. And then we're going to get two equations in a and b, and we will solve them simultaneously, okay? Filling us full of glee. So there's the first one. P of 1 equals 1 to the 4th plus 2 times 1 cubed plus a times 1 minus 14 times 1 plus b. So let's clean that up and make that equal to 0. And what do we get? We get that, okay, equals 0. So therefore we're saying that a plus b equals 11. There's our first equation in a and b. Now we'll do the same thing for x equals 3, okay? Plugging it in, you get all that stuff. And we equate that equal to 0, and we just clean it up and get an equation in a and b. Goodness gracious, it's a bit of a mess, isn't it? So it all comes down to 9a plus b equals minus 93, okay? Now we're just going to solve those simultaneously. We subtract 1 from 2, which will get us 8a is equal to, what's that, minus 104. Good heavens. Therefore, how does that all work? So a would be, that's good, minus 13. Now, we substitute for a equals minus 13 into 1, okay? So if minus 13 plus b equals 11, therefore b would be 24. There you go, guys. We worked it out, didn't we? So therefore, a is minus 13 and b is 24. Marvellous. Now, here's how you do that question on your CAS device if you are technology enabled. You put the polynomial in, call it f1 of x or whatever you'd like to call it, and then you go into menu, algebra, solve system of equations, okay? And then you just simply plug in f1 of 1 equals 0, f1 of 3 equals 0, knowing that you've defined f1 of x up here in the memory of the device, and you're solving that for a and b, and look at it, just comes out like that. Amazing. Computers are amazing. All right, another example for us. In this example, we have to show that x plus 1 is a factor of this, and hence find the other linear factors. All right, guys and gals, so if x plus 1 was a factor, then plugging x is minus 1 into this would get us a 0 result. In other words, 0 remainder, which means that x plus 1 is a factor. So plugging x minus 1 in to the thing, we get that, and that comes out to be minus 1 minus 4 minus 1 plus 6, which gets us 0. So therefore we've done it. Therefore x plus 1 is a factor, and that's proven. All right. Now we have to use that fact now, and hence find the other linear factors. Now what I've done here, you can long divide if you want to your heart's content, ladies and gentlemen, but for me, I'm going to do it this way, using what I call the alpha technique, equating of coefficients, okay? But if you want to pause me and long divide, have a bit of fun doing that and come back when you're ready, okay? So with the equating of coefficients technique, I'm saying x cubed minus 4x squared plus x plus 6 is equal to x plus 1, a linear factor, times some quadratic, okay, to get back to the cubic. Linear times quadratic gets us cubic, and I also know that the leading term here, the x cubed term, comes from the multiplication together of the two front terms in the bracket. So therefore that has to be an x squared term. I also know that the back term here, the constant term, comes from multiplying the right hand constant terms in the brackets. So therefore this has to be a plus 6 to make 1 times plus 6 getting 6. The only thing I don't know, obviously, at this point, is the value of the coefficient of the x term, which I'm going to call alpha. But I will work that out using equating of coefficients. So if I take, for example, the x term on the right hand side after multiplying all of this out just to get the x term, and then I equate that with the coefficient of the x term here, which is 1 on the left hand side, we can work out what alpha really is, okay? Now what I'm saying is this: for this first term in the linear factor bracket, we've got here x times 6 would get us 6x, wouldn't it? Yeah. And for the plus 1, then if I multiply the plus 1 by this middle term, I'll get alpha x, okay? So the right hand side expansion of x gets me 6x plus alpha x. And then looking at the left hand side, I can see that I have plus x. So therefore 6 plus alpha must equal 1, okay? There you go, and therefore alpha would be minus 5. Easy peasy lemon squeezy, guys. Therefore, I've got this. Now, that's a tremendous step forward, which you can also achieve by long division, of course, if you like long division. Now, what I've got to do now is I've got to factorize this quadratic into two linear factors. And I think that's going to be pretty easy, because I can see that 3 2s are 6 and 3 plus 2 is 5, so therefore I think we've got it. Is that what we have to do? Find the other linear factors. Yes, we did it. How marvellous, how marvellous. So the other linear factors were x minus 3 and x minus 2. Now, if you said for your answer that x equals 3 and x equals 2, you'd be wrong, because you would be giving roots, okay, not factors. They are asking you for factors, okay? All right, another example before we finish this segment. Just straight factorization question. So with cubics, as you know, we have to guess and check to find our first root. So we'll try x equals 1, which would mean that x minus 1 would be a factor. So if we plug in 1 into that equation, I think we're getting a 0 result. We are. How beautiful. So that was pretty easy. So therefore x minus 1 is a factor. So therefore we can write our polynomial as x minus 1 times, now the same kind of idea as in the last example, a quadratic times a linear gets a cubic, so this has to be a quadratic in here. The front terms give you x cubed multiplied together, so that must be an x squared there. We've got a plus 6 on the end here, so therefore if that's a minus 1 in there, that must be minus 6, so that they multiply together those rear terms to get the rear term here, the constant term, as a plus 6. Now all I've got to do is work out what this alpha is using the same technique as I just did before. We're going to use the x term again. So you pause me and see now if you can work out what the x term would be from the expansion of this, okay? All right, so we've got minus 5x on the left gets you, there's minus 6x from the front term and minus alpha x from that minus 1 term there, minus 1 in the front bracket, okay? So, all right, now we've just got to equate the coefficients and therefore we can do that. Therefore, we can say that minus 5 equals minus 6 minus alpha. Therefore, alpha would be minus 6 plus 5, which would be minus 1. So there we got that. Oh, that's very nice. Look, again, we've got 3 2s are 6, so we can just organise that pretty easily. And we've got that. So therefore, it's a done deal. And we're good to go, okay? See you later.